Unit 4, congruent triangles. In Unit 4, Day 3, we're going to talk about congruent triangles, side, 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 and side angle side. So it's going to be two parts to this video. Part 1 is going to be congruent triangles. When you finish, you'll do your classwork. You'll turn that in, and then you'll go to the next video. So congruent triangles or congruent shapes, they're going to have the same shape and they're going to have the same size. So in this section, we're talking about congruent triangles. Same shape, same size. So basically, when we say the triangles are congruent, this means that all the corresponding parts. What are the corresponding parts? Well, they're going to be angles and they're going to be sides and they're going to be congruent. Once we determine that they are congruent, we are going to write something that's called a congruency statement. So when triangles are congruent, we can write a congruency statement. Here's the congruency statement here, and it states that triangle ABC is congruent to triangle DEF. So take a look at this. If I look at angle A, I notice that I have one marking here. So which angle over here has one marking? It's angle D. Which angle has two markings? B. Which angle has two markings? E. 3 markings C. 3 markings F. Take a look at my statement. What's the first letter? A. What's the first letter over here? D. And they both have the same marking. Why? Because these triangles are congruent. So here, if you notice, I have the two triangles and I actually rotated the triangle. So it doesn't matter that I turned it and the orientation is not the same as the original. If I write my congruency statement, then angle A is definitely going to match up with angle D. Angle B is going to match up with angle E. So the orientation doesn't matter. It still has the same size and the same shape. So you're going to hear us use the initials or the letters CPCTC. So if we say CPCTC, what we're saying is that the corresponding parts of congruent triangles are congruent. So if we find out that two triangles are congruent, then we could say, hey, one angle here is the same as the other angle over there. So basically, if we know the two triangles are congruent, then we know that every pair of corresponding parts are also congruent. Here, the first thing we want to do is we definitely want to make sure that we read the directions very carefully. It says list all congruent angles and sides given the congruency statement. So we're starting off, we do not have a picture, but it's telling us that triangle JKL is congruent to triangle PQR. So let me show you what we can do with that. So what I've done is I've listed all the angles in triangle JKL. And what I'm going to do is I'm going to show you what they are congruent to. So take a look. I've matched up all the corresponding angles. JKL, which is the first, the second, and the third. And I've matched them up to corresponding angles PQR, which is the first, the second, and the third. We're going to do the same thing with the sides. So take a look at this. I've written down the sides, JK, KL, and JL. And what have I done? I've taken the first two letters here, JK, the last two letters, KL, and then the first, J to L, and I've written them down. Now what I'm going to do is I'm going to set them equal to the corresponding parts. So here you have it, P to Q, Q to R, and P to R. So I took the first two letters in the first triangle and matched it with the first two letters of the second triangle. I took the second and the third letter of the first triangle and matched it with the second and the third of the second triangle. Why? Because once we find out the triangles are congruent, then we know all the parts are congruent. I'm going to go ahead and write another valid congruency statement. The one at the top says that JKL is congruent to PQR. I'm going to rearrange the letters. So I'm going to now say the triangle, and I'm going to write it backwards, LKJ is congruent to triangle RQP. Notice how I kept all the angles in the same spot. So there is another valid congruency statement. Here, we're going to take the time to read the directions. They're giving us a congruency statement, and then they're saying to complete each of the following statements. So when I take a look at the first one, it says KM. I don't want to look at the triangles because I notice they are oriented in different positions and directions. So I look at KM and I want to go up here to my statement. And when I go to my statement, I notice that K is the first letter and M is the third. So I'm going to look over here. What's the first letter? A. What's the third letter? C. So I write KM, segment KM is congruent to segment AC. Take the time to fill in B and C and then hit play. There you have it. We have corresponding triangles and therefore we have these corresponding parts. Take the time to match up angle Y, angle K, and angle ACY, and then we'll go over it together. So take a look. Angle Y, which is in the middle, matches with angle P, which is in the middle. Same angle K matches with angle A. And then this one, we name angles with 3 letters and we concentrate on the one in the middle, which is C. So I'm going from A to C to Y. So when I look at my statement, I'm going from A to first, C to third, to Y to second. So I'm going 1, 3, 2. And I'm going to do the same thing with my other triangle. I'm going to go from 1 to 3 to 2. And that's K to M to P. Try the last two where we're saying that triangle MPK is congruent to something and triangle YAC, and then hit play. There we have it. Triangle CYA, and the answer to H is triangle PKM. You have any questions, push pause and go talk to your teacher. Now we get down to the application part. This problem says find the values of X, Y, and Z. How do we find the values of X, Y, and Z? We find them one at a time. First thing you notice is that we're given a congruency statement. So what I want to do is I want to match up corresponding parts. I'm given information about the sides, not the angles, just the sides. So I'm going to write down corresponding parts and we're going to take it from there. So first things first, I wrote all the corresponding congruent parts across the top. And now I'm going to use substitution to show what each part is congruent to. So after substitution, here are my setups. 12x minus 7 equals 53. 57 is equal to 5y minus 33. And 3z plus 14 is equal to 50. Alrighty, x is 5, y is 18, and z is 12. Let's take a look at this one. Oh my goodness, there is no picture. So here's a word problem. What is it that we can do? We could A, draw a picture, or B, write our congruency statements based on what we see here, that triangle DEF is congruent to triangle JKL. I prefer to write out my congruency statements and then use substitution. So first things first, here are my congruency statements. One side, DE is congruent to JK, EF to KL, and DF to JL. Let me make sure I put my bars across the top to show that they are segments. There we go. Let's go with substitution and see if we can solve and find these variables, X and Y. So notice after I wrote all my statements down and I wrote in using substitution, what each one was equal to, I didn't have a value for KL. So when I looked up here, I didn't have a value for KL. Is that going to be okay? Well, we'll see. What do the directions say? It says solve for X and solve for Y. Well, take a look at this. Here is Y here, so I should be fine. And then here is X over here, so I don't necessarily need this information. Remember that in geometry and in other subjects, sometimes we give you information that's not necessary. So we don't need it. Go ahead and solve for X and Y and see what you get. Here you have it, X is 17 and Y is 13. Okay, so summary of learning. We're going to concentrate on some of the main points. The first one is congruent triangles have congruent parts. So take a look at these triangles here. I have a triangle with a side of 8, a side of 6, and a side of 7. And I have another triangle here with a side of 6, a side of 7, and a side of 8. Are they turned the same way? Absolutely not. But do I have sides that match up? Yes, I do. Are the triangles congruent? Yes, they are. Congruent triangles have congruent parts. So I have 3 sides that are congruent to 3 sides here. And actually, if the triangles are congruent, then we also have congruent angles. So our next point that we're going to focus on is the congruency statement. So here, you're given triangle MAT is congruent to triangle HIR. What does that really tell us? So as you notice, triangle MAT is congruent to triangle HIR. We could number these 1, 2, 3, and 1, 2, 3. So when we get ready to list corresponding parts and we label MAT here, we want 1, 2, 3 to match up with 1, 2, 3. So angle M is congruent to what? Angle A is congruent to what? And angle T is congruent to what? You got it. We would write angle H, angle I, angle R. But how would we do the sides? So here we go. I'm writing the sides and I'm looking at side MA, which is 1 and 2, side AT, which is 2 and 3, and side MT, which is 1 and 3. So what are the corresponding parts over here? Go ahead and write them in and then check your answer. These are notes, and so you could actually put these on page 10 or in the front of your booklet or the back of the booklet or the cover or your notebook. It's up to you. There you have it. And let's not forget the last thing is that if you write a statement, then substitute the values to problem solve. This is what you'll do if they give you a statement and they say DE is equal to 2x plus 3 and FG is equal to 5x plus 3 or whatever the case may be. Just make sure you write out your statement and then substitute the values. That concludes part 1 of day 3 lesson. You can now get the worksheet number 4 from your teacher.